Assalamu alaikum. Today we are discuss about bitmap index in our database management system course. We are group 11 and let's continue. This is my teammate and I am Johair Akhtar. My ID is 241153000. In this slide, we see the definition of bitmaps. Basically, bitmaps index is a searching label in by the bit value 0 or 1. It's searching the value by bit vector per table. In the second table, we see, let's example, if one row matches the value, 0 row does not matches the value. And we also use here and or not for our answer queries. Why this is based and where it is based in low coordinate. Few distinct values are based for the bitmap index. For example, to find in a massive data the male or female. Let's identify the male as M or female in F. But in the bit, we identify the male as 1 and female as 0. And sort, we find the data in a massive data set in very few seconds by the 1 and 0. Also, let in the active or inactive. Let find if in a Facebook user is active or inactive or a member in some club or where he active or currently not active. To find this, we active status is 1 and inactive status is 0, and we find a massive data from this dataset very easily. Also as the income level from L1 to L5. Now, what is the benefit of this bitmap index? It is very fast query and take low storage, and also it's simple bit logics. And where is not is worst from others, a high coordinated is not good for uh, high data big data storage, and slow one update, don't write overhead. This all from me. Now my next teammate will continue. Thank you.
Is Kamila Mukti and my ID is 2411531. Now I will explain a multi-value example using income level where possible values are L1 to L5. Suppose we have 5 records. In bitmap indexing, we create a separate bit vector for each income level. For L1, the bitmap is 00 on 00, meaning only the third record has income level L1. For L2, the bitmap is 0 on 001. So record to have 5 belong to L2. For L3, the bitmap is on 00 on 00, meaning record on and for having L3. And L4 and L5 are zeros because no record contains those values. An important observation is that each row has exactly on across all index. Original data accurately making starting efficient. Now, how do we query using this data? We use bitwise logical operation. First, and it return on only when both bitmaps have on. This is used when multiple conditions must be true. Second, or it return on when at least one bitmap has on. This is used for either on condition. Third, not. It flips all bits, useful for execution exclusion queries. For example, suppose bitmap is 01001 for income level 2, applying and gives 01000, meaning only record 2 satisfied both conditions. Applying or gives 01011, meaning record 2, 4, and 5 satisfy at least one condition. This logical operation allows very fast query processing. Next, my teammate will continue this presentation.
My ID is super11592. Let's look at the structure of bitmap index. The key idea is simple. For each distinct value in a column, we create one bitmap, a sequence of bits, one per row. The length of the bitmap equals the length of total number of rows in the table. If a row contains that value, we put a 1, otherwise a 0. These bitmaps are extremely compact. In fact, they can be compressed and further using techniques like byte-aligned bitmap compression (BBC) or word-aligned hybrid (WAE) compression, which makes them very strong, efficient, and fast for query processing. Now let me walk you through a concrete example using gender column from our employee page. We have 5 rows, label row 1 to row 5. Gender has 2 distinct values, male and female, which are M and H. We start by scanning the gender column. For the bitmap representing M, we go row by row. Row 1 is M, which is 1. Row 2 is F, which is 0. Row 3 is M, which is 1. Row 4 is F, which is 0. And row 5 is M, which is 1. Next slide. So the bitmap for M is 10101. For F, we do the same. Row 1 is 0, row 2 is 1, row 3 is 0, row 4 is 1, row 5 is 0, giving us 01010. That's it. Just 10 bits to represent all the gender information for the entire table. Notice these two bitmaps are mutually exclusive. They never both have one in the same position, and together they cover everywhere. Next, my teammate will show multiple examples with income level. Thank you.
Assalamu alaikum. My name is Sakibul Hasan Sakib. My ID is 241150048. Now let's solve a real query step by step. Here gender is equal to F and income is equal to L2. In step 1, retrieve the bitmaps. Gender F is 01010 and here income L2 is 01001. Let's perform the bitwise AND. Row 1, 0 and 0, which is equal to 0, and in row 2, 1 and 1 is 1. Row 3, 0 and 0 is 0. Row 4, 1 and 0 is 0. And for row 5, 0 and 1, 0, 1, 0, 0, 0. Now, row 2 satisfies both conditions. This is extremely fast. CPUs can do this in parallel. Next slide, please. Now, perform evaluation. Advantages: space efficient for low cardinality, very fast and or queries, great for read-heavy OLAP workloads, support compressions. Limitations are poor for high cardinality columns, more than 100 distinct values, expensive updates, not suitable for OLTP. Ideal use cases are data warehousing, columnar database, and business analytics. So that was all from me. Now my next teammate will cover advanced topic and conclude. Thank you.
Thanks. Let me cover some advanced topic. Aggregation, speed up, count operations are extremely fast using the CPU pop count instruction, which count 1 second in a bitmap in a single cycle. Hybrid index combine B tree for high coordinate columns with bitmap identity. For low cardinal opens, getting the best of both worlds. Modern improvement, routing bitmap use in Epic Spark, Redis, and Drift. Handles million of values efficiency using compressed contents. Please change the slide. Conclusion, bitmap identities are perfect for read-heavy, low coordinated seniors. They turn complex Gonic queries into simple bitwise operations. With compressed and modern patterns like routing, they remain relevant for big data. Key takeaways: small footprint, lightning fast queries. That's all for my side. Thank you for your attention. Thank you.